Okay, our goal is to just get through these 4 problems. These are not easy problems. Okay? And so these are the problems if you had them on the test. This is where we kind of get 50% of you are going to get them right, 50% of you are going to get them wrong. Okay? So let's dig in. We look at the first one. It says find the derivative of the following, and you may need to use more than one rule in this situation. I will not tell you on the test when you're going to have to use more than one rule, or when you have to use a chain rule, or when you have to use a product rule, or when you have the quotient rule. So as you glance at that, what rule or rules do you think you're going to have to use in this situation?
Quotient.
For letter A.
Chain.
Product and chain. Notice as we read it, negative 3x squared, so this is a function in and of itself, times the cosine of 4x. So I see that I have product and I see that I have chain. Which one do we set up first? Well, it's in the order of operation. Cosine of 4x, negative 3x squared, and then you multiply them together. So the last thing I did was multiply them together, so that's the first thing that I set up. So I have f prime of x is equal to, and the derivative of f is?
Negative 6x.
Negative 6x times the cosine of 4x. Plus, here's where I like to just write f, or minus 3x squared, times the derivative of cosine of 4x. What rule do we use to find the derivative of cosine of 4x? The chain rule. Some of you already see it, but again, we have cosine of u, we have 4x, we have 4, we have negative sine of u. Eventually, we don't really need to set those boxes up when we do things like the derivative cosine of 4x. We can see that the derivative is negative 4 sine of 4x. So that will change this to a positive 4 sine of 4x. Anytime you use the product rule in conjunction with the chain rule, you must take out a common factor. So this is not my final answer. I'll go ahead and take this a step further by just multiplying those terms. Cosine of 4x, and here I have a plus 12x squared sine of 4x. And now, what is the common factor I should take out?
Negative 6.
Negative 6x, yep. And when I do, I'm left with a positive cosine of 4x. And it looks like what is left?
Minus 2x.
2x sine of 4x.
Yes, so you combined the 3x squared and the 4.
Yep, 3x squared times 4 is my 12x squared. So, product rule with the quotient, or with the chain rule, it is written in factored form. Helpful, it tells me it crosses the x-axis at 0. At least I know a little bit of information. How about letter B? What rule or rules should we use in that situation?
Quotient and chain.
Quotient and chain. So what do I set up first? Do I set up the quotient rule first or the chain rule first?
Quotient.
Who's right?
B.
Okay, as you think about it, please look here. Okay, and maybe you're saying the same things. I just want to make sure we understand. This is the square root of a quotient, right? So that means that the chain rule is the over-encompassing rule. Okay? The square root of 2 minus x over 2x plus 3. So you would plug something in for x, you'd evaluate the bottom, you evaluate the top, you divide them, and at the very end, you would take the square root. You see that? So the first thing I'm going to set up in this situation is, and I'm going to use space over here because I don't have a lot of room to write. Sorry if you need to take out a scratch sheet of paper, but I'm going to set my chain rule up over here. I have u to the 1/2. And what is on the inside? Over 2x plus 3. So can everybody see that when I take the derivative of that, that will require the use of the quotient rule, right? Okay. You've done this many times. What is the derivative of u to the 1/2? 1 over 2 roots of u. It's 1/2 u to the negative 1/2. Low key?
Yeah.
Okay. What happened to that kid? Just like, he's going to state, going to state, going to state, going to state. He's on fire, okay. So let's take the derivative of this. Derivative of the top. -1 times the bottom, 2x plus 3. Minus the top times the derivative of the bottom. Derivative of the bottom is 2 times 2 minus x. That all sits over 2x plus 3, that quantity squared. We have some simplifying we can do at the top. I have a negative 2x minus 3 minus 4 plus 2x over 2x plus 3, that quantity squared. So what are we left with at the top? Is everybody okay with that derivative?
Yeah.
Then remember what we have to do. We have to take this and plug it back in for u and multiply the two expressions together.
Really?
Yep. NT is looking scared by the process.
What do we have to do?
We have to take this, plug it back in for u, and we're going to have to multiply it by that. Oh, no, it's not too bad. You just got to be careful. Try not to do too many things at once. Watch how this is going to happen. 1 over, the 2 is a 2 over 1. So I'm going to write it as 2 over 1 times the square root of that thing, or the square root of 2 minus x over the square root of 2x plus 3. I simply took the square root of the top and the bottom. Now I multiply that by -7 over 2x plus 3 quantity squared. I'm almost done here. I just need to make sure that this piece here is not expressed as a complex fraction. So as you try to work through this, can everybody see that the top is a 1 over 1? Now I'm going to multiply by the reciprocal of the bottom. And so the reciprocal of the bottom will give me the root of 2x plus 3 over 2 roots of 2 minus x times a -7 over 2x plus 3, that quantity squared.
Yes,
Wasn't
sir.
2x plus 3 at the top. Reciprocal. Because we just multiplied the function. Oh.
So I took
Oh,
that,
I got it.
multiplied by the reciprocal of the bottom to get that. Yes, sir.
Why are we timesing those two together in the first place?
Because the chain rule says that you take the derivative of this guy, which is here, and multiply by the derivative of that guy, which is there.
What?
Multiply those two together.
These are the reciprocal.
Alright, so then what's happening with the reciprocal?
So I'm trying to simplify this complex fraction, so I have a 1 over 1 divided by that. So I'm going to take 1 over 1 multiplied by the reciprocal of that, which is going to give me this right here. I'm going to multiply by this reciprocal, so this piece is going to come to the top, that piece is going to go to the bottom. We are almost done. We have one last thing to simplify. Can anybody tell me the square root is what power?
1/2.
1/2 power. So I'm just going to write a 1/2 there. Notice that we have a 2x plus 3 in the top, and we have a 2x plus 3 in the bottom. So those are common bases. So what can you do to the exponents? You can subtract them, right? And so 2 is larger, so 2 minus 1/2 is going to be 3/2. So I'm finally left with a -7 over 2 roots of 2 minus x times the 2x plus 3 raised to the 3/2 power. Kind of a nasty problem, huh?
Yeah.
Yeah. Fortunately, you're very, very intelligent. Imagine how hard this class would be if you weren't. Which, by the way, like I just looked, the average grade in this class I think is like 95.8%. So time to make it harder, huh?
No.
No.
All right.
No, what just happened?
There's a go back and watch it tonight on the video.
No,
You'll be
no.
okay. How is this one similar to the last one? And how is it different than the last one? Let's start with similar. How is it similar?
Quotient.
Quotient rule and the
Change.
chain rule. How is it different though?
No
Different exponent.
There's no square root, there's different exponents. It starts with the,
Go back and watch.
this one starts with the quotient rule. Because if you think about it, you plug something for x, multiply 3, minus 5, take it to the fourth power. Then you 2 minus that, take it to the 6th. And the very last thing you do is divide. So we're going to start by setting up the quotient rule. And I'm going to organize my work right over here. Again, I'm sorry if you're running out of room. You might have to attach a separate sheet of paper. I always forget to add more room on during this time. But I'm going to set up two chain rules here as I do my work. And I'm going to have my u to the 4th and my 3x minus 5. And I'm going to have my u to the 6th and my 2 minus x. So I have 4u cubed. What's the derivative of 3x minus 5?
3.
Isn't that nice? Remember, every time we used to take those derivatives, we use f of x plus h minus f of x all over h, when does h goes 0. Now we just, easy, thank goodness of the power rule. Derivative of our u to the 6th, Brody is not allowed to answer. We have 6u to the 5th. And the derivative of 2 minus x is a negative 1. So Gilly asked before, why are we multiplying these things together? Remember that in context of the chain rule, we multiply those two to get a 12 times 3x minus 5 to the 3rd power. And on the bottom, we multiply them, we get a negative 6 times 2 minus x to the 5th power. We all okay?
Yes.
Okay,
We got the derivative.
so let us move on from there. We just did that because we know we're going to use them, but we have to start by setting up this quotient rule. And so we have f prime of x is equal to the derivative of the top. What did we say is the derivative of the top?
12 times 3x minus 5.
Times what? The bottom. So it says NT in the deep voice. I need some space, so I'm going to erase. Plus or minus? Minus. What was the derivative of the bottom? Yeah, so that negative is going to switch that negative to a plus, and I have 6 times 2 minus x to the 5th. And I just have the top, which is 3x minus 5 to the 4th power. And that all sits over the bottom, which is 2 minus x to the 12th power. Thank you. The last problem is easy compared to what we're doing right now, so don't worry.
This looks a lot easier.
Everybody agree that like there's some 2 minus x's up in both parts here? So we are going to get, a lot of that denominator to cancel off. But in the quotient rule in this situation as well, you're going to want to take out a common factor. So I think we've done a really good job of preparing you the past couple of days for this moment. I just want to focus on the numerator and only the numerator, okay? I have one term in red, I have one term in blue, okay? So I'm going to look at those two terms and compare them. Let's look at the constants. What do they share in common?
6.
They share a common factor of 6. Now we look at the 3x minus 5s. They share a 3x minus 5 to the 3rd. And then they share a
2 minus x to the
2 minus x to the 4th.
2 minus x to the 5th. Good. Times, so that's the common factor we took out. So what's left from the red?
2 times 2 minus x.
Good. What goes next?
3x minus 5.
Plus, yep, the 3x minus 5.
How does this help?
All over
Simplify it.
2 minus x to the 12. Great, so I've taken out a common factor. So I have 2 minus x to the 5th in the top, 2 minus x to the 12th in the bottom. Kira, you're the only one allowed to answer right now. Say anybody other than those 3 boys over there. This will reduce to give us 2 minus x to what?
12. No.
Minus the 5.
Oh my god.
Thank you. And I have my 6 times 3x minus 5 to the 3rd. And here I can combine these terms together. Notice that there's an opportunity to combine. I have a negative 2x and a positive 3x is going to make a 1x. And a 4 and a negative 5 make negative 1. And there's my derivative. 6 times 3x minus 5 cubed times x minus 1 over 2 minus x to the 7th.
Again, so
Yeah.
when did you get the x minus 1?
So as I combine these terms right here, I would get a 4 minus 2x, and here I have a 3x minus 5. So as you combine those like terms, 3x and negative 2x makes a positive x, and a 4 minus 5 makes a negative 1.
So that's the answer.
Yeah. Can you guys agree that you're probably going to have to practice that problem in your homework and probably do it again so you got before you probably get right on the test? And just to be clear, I want to make everybody, help us all see in a perspective here. Everybody talks about how they love algebra, and algebra tends to be their favorite subject. In fact, if you ask math teachers what they would feel most comfortable teaching, just about every math teacher would say, well, I want to teach advanced algebra 2. That's kind of their comfort zone where they want to be. Is it 90% of this algebra? Yeah, actually not a lot of it's calculus. So let's admit that the algebra is usually what gives us problems. And ideally what you want to get to is you want to get to that point where when you're taking your next math class, your next physics class, your next chem class, whatever it is, that the algebra is of no issue to you. And that will be the separator between you and other students in college. Is some of them will still need help with the algebra. You won't, because you are excellent algebra students. Now let's all admit algebra every once in a while bites us, right? Okay, there's the algebra of calculus, which is a lot more challenging sometimes than the other algebra we see. So, we're not holding back punches, folks. Last example. Talk to the person next to you. What do you think we set up in this situation? What do you think we set up in this situation? Hint, it does involve more than one rule. Go ahead, talk. What do you think? Go.
Oh, looks like I'm not doing it. I don't know.
Power over.
From a job. I don't know what we do first.
That's true.
I'd say that's my first job.
Okay, I heard the Pythagorean theorem. I heard the quadratic formula. Those are great. So let's just make sure we embrace some of those answers that are not quite right, but they're good thoughts. Did anybody suggest the product rule? And why would you say product rule?
Because they're times and each other.
Exactly. So I want to be clear about this, and that's why we are to this point, is to try to help you see. Negative 8 times the sine to the 4th of 4x minus 2 does not require the product rule because negative 8 is just a constant. If it was negative 8x sine to the 4th of 4x minus 2, now that requires the product rule. Everybody see the difference there? That is a big mistake that people continue to make, not just on this test, but as we move forward. Again, if you had 4 tangent of x, that does not require the product rule. But for x tangent of x, that does require the product rule. See the difference? Let's keep that in mind. So this, if you said it, is a double chain rule problem. Double chain. Let's set it up. What sits on the outside?
Negative 8.
The negative 8,
U to the
u to the 4th. Very good. What is it that I'm taking to the 4th power? Sine of 4x minus 2. The derivative of negative 8u to the 4th, negative 32u cubed. And the derivative of sine of 4x minus 2, if you haven't noticed, yes, that does require the use of the chain rule. Maybe you want to set up the boxes, maybe you don't, that's fine. I messed up already. I'm gonna scratch that off and just say sine of u and 4x minus 2. And the derivative of 4x minus 2 is 4. And the derivative of sine is cosine. Good, Hayden. 4 cosine of 4x minus 2. For this derivative, we will go ahead and multiply those two expressions together, right? So 4 times negative 3 is negative, or 4 times negative 32 is negative 128. We have the sine cubed of 4x minus 2. And we have a cosine of 4x minus 2. So taking this guy times that. So I have the negative 32 in with the 4 right here at the 128. I have the sine cubed of 4x minus 2, but I still need the cosine of 4x minus 2 here. If you chose to put the cosine of 4x minus 2 out by the negative 128, that's fine, but you cannot have it cubed. Okay. We only have these short problems left tomorrow. Okay? So, yep, that's it.
You should go back to it.
So you guys are ready to continue your work. Tomorrow we should be able to get done, I would say, within about 12 to 15 minutes, and you should have the rest of the time to work. I'll get your study guide to you tomorrow as well. You'll have Wednesday and Thursday to work and practice. Work and practice.
Wait, so which ones are, these ones are the hard ones?
Let's try to keep things so that we are,
So where's the-
how should we say it? Let's try to keep our 95.8% average going. You guys are now ready to do all of these problems. All the way up until 25, I should say. You can stop at 24. When I hand you guys the study guide this time around, I just want you to